Hello, I would like to present our paper. The title is The Effect of Floor Diffuser Configuration in Underfloor Air Distribution System on Thermal Comfort in an Educational Space. Um, we have tried to investigate different location for the inlet and outlet air ventilation. Usually the basic air circulation system using nowadays is the mixed air circulation, where both supply and exhaust is happening from the top. There are some disadvantages with this system, and so the amount of the air which it needs to reventilate, and it always force the HVAC engineers to design a larger mechanical machines, and at the same time this way of air circulations and air ventilations is helping for increasing the air pollutions, because the air particles are always suspended on the air under these circumstances. So we have used the underfloor air distribution system. The abbreviation is UFAD, and for that we have used hexahedral mesh, generated using Gambit software, while OpenForm version 2.2 with BioEnt business simple form solver is employed for the numerical modeling of the governing equations based on finite volume techniques. So and under floor um, air distribution system has been considered for this study. The existing equipments are 30 diffusers, 6 supply outlets, 8 lights, and 30 occupants. So these are all fixed in all four the variations, and the boundary conditions are wall, ceiling, and floor. These are adiabatic, so we try to keep the U value as less as possible. So they are all condition zones. In other words, so it's to the under investigation room environment. Intake air flow rate for all the simulations is equal to 0.218 meter square second. For the whole space, air change is equal to 5, and intake air temperature from all the diffuser is 18. So again, this is happening in all the rooms. And the closing coverage ratio, the heat flux of occupants and the heat flux of lights are assumed to be 0.8, 104.68 watt and 60 watt respectively. So these are the boundary conditions in our cases. The case study, as mentioned, has been created since the case study was symmetrical. In our case, fortunately, the software considered only half of the models, so it really helped us to decrease the process of simulation faster. And then as automatical features of the software, we could get the same result from the other part of the buildings. So this was the reason that we show half of the rooms as a simulated case study here. And so for the mesh independency study, what we have done was to create 3 different mesh systems with increasing number of cells, as from 400 almost 75,000 to up to 2,400,000, and also 1,145,000. thousand, and they have been examined to see from which number of mesh we can get the same results, which obviously we could see that between 2 million to 4 million, we could not see any difference, honestly. So that's why we fixed the mesh density for around 2 million. And obviously, considering the different parts of the educational space, the mesh density has been different. So where we have the contact, and when we were really curious about the hygienic dissatisfactions, and we wanted to see more information regarding that part, we had increased the number of meshes. But while in higher rooms height, we decreased the number of mesh. So because this was not really the questions in our case. And here we are showing that around we have selected for the mesh independency, as mentioned, 3 different models, and in these 3 different models we have specified some points, and after that we could understand that, as mentioned, that above 2 million mesh, we really didn't have any more difference, so we kept for 2 million, as mentioned. And then we considered a 1 to 5 meter the occupied zone, and then above it, obviously, because then the temperature could be different, and then the normal height of the human being is we consider it around 1.7 to 1.8. So above that, this is unoccupied zones. We consider it as unoccupied zone. The reason is that we wanted to have the most correct, and the most minimum area, and to find out what is really going on where people are sitting and in their height. So, as mentioned, 4 different cases are considered. In 4 cases, a number, dimensions, and intake air velocity of diffuser were defined by considering the permissible cubic feet per minute of the supply air entering the room. The velocity of and temperature of the air are calculated in accordance with the standards of ASHRAE 62 for an educational space supplied by underflooring diffusers system for the first 3 cases, and with the guidelines of the usage of displacement ventilation system for the 4th case in the investigated cases. So the placements of diffuser are considered to be under the seat, in front of the seat, in the corridor, and on the lower part of the walls. Here I could see that, so in A models the diffuser are under the seats, while in B models the diffuser are in front of the seats, and in C models they are located in the corridors. You could see in a plan view, and then in a D model they are located on under parts of the walls. So where we have 2 here, and obviously since the model is symmetrical, there are 2 in other side as well. So here we could see the thermal comfort evaluations, so distributions of predict mean vote, PMV, in 4 different cases, and at the same time we could evaluate the local thermal discomfort and stratifications evaluations, so in different cases. Obviously, the cases where the diffuser was under the seats or in front of the seat, we could see the cooler air, and then a little bit more, dissatisfactions in case of the hygienic comforts. While in the cases where the diffuser were in the corridor or in the wall, there are more, I think, quite more comfortable situation. Obviously, here is the local thermal discomfort and stratifications, evaluations, and the whole the temperature. So you could see that the case A, the case 1, 2, 3, 4 indicated in these. So we wanted to see really what is the highest temperature difference. As you can see in the case of number 2, you could see that the temperatures are rising from 19 to 24, while in the case 1, 2, 3, it is almost to 23. So the distributions of air velocity fields and their magnitude contours around seat and occupants in the occupied zones are shown here with velocity magnitude. So you could see the different situations considering the locations of the diffusers. So, and then in conclusion, we have had some foundings, but we mostly try to explain each part separately. So the situation in each case is following. The minimum room temperature in the occupied zone were achieved by placing the diffuser under the seat, which led to have the most energy efficient ventilation system in terms of providing thermal comfort temperature in the occupied zone. In this case, the temperature difference between the floor and the head is also within the permissible range. In the case that the diffuser were located on the lower part of the walls, due to the fact that the middle row occupants of the class are further away from the diffuser, the most dissatisfaction occurred in this case because of having the highest temperature variation along the heights and the unstandardized temperature difference between floor and the head. In this case, that the room temperature in both occupied and unoccupied zones were the highest temperature among other cases. The lowest amount of draft rate occurred when diffusers were placed in front of the seats. Placing the diffuser on the bottom part of the walls doubled the possibility of having draft, which would reduce the energy consumption in cold season and increase in the hot season, obviously. All the results of the case in which the diffuser were located in the corridors were within the permissible range. The results of simulation showed that the thermal comfort of the occupants is highly influenced by the diffuser configuration in the space. In conclusion, it was established that with a well-designed placement of the ventilation system diffuser, the underfloor the diffuser system can provide appropriate ventilation with the permissible limits of occupants' thermal comfort and health conditions in crowded place. So furthermore, investigation also is required in terms of various geometry and different functional spaces with different intensity. So it is recommended to follow up the case in such forms too. So thank you very much. Thank you for the attention.